Hello and welcome to the third lecture in sixth chapter of our comprehensive course on AI, machine learning and data science. We are talking about pandas at present, and so far we have learned some very basic things: how to create a panda series from a Python list, this much pd.series, and in bracket provide the list. How to create a panda series with a custom index. So pd.series in bracket provide first the data, that is the list containing data, and second provide the other list containing index, custom index which you want. How to create the Python data frame using a dictionary. So this is that data which is given in the form of dictionary, and we have created pandas data frame from that. How to access individual column, either single column or later on, yes, here multiple column. The method is you have to write df and then in the square bracket you have to specify the name of the column either as a single string, or you can pass, if you want to access multiple columns, then names of the column as a list of all column names, and column names must be in the form of string. Okay, then now we want to talk about this thing, that is importing pandas. Yes, we also talked about in previous lecture how to access individual row. So I told you that if you know the index of the row which you want to access, then you can use iloc, index the location df.iloc. But so this will give output of 0th row. I can write 1 here, then it will give first row, then second row, and so on. And similarly, I can also find in the value of an entire row of a data frame by putting some condition. If I don't know the value of index, but I know that find the row containing row where total population has value 340. So here I'm creating my data frame, for example this data frame or this one, right? And this is the row which has population 340, this. But I don't know, because here it is visible, but every time it will not be visible. I want to programmatically find. So at that time you need to use loc command, that is loc, location, and in that you have to df.loc, and then in bracket you have to write the condition that which location. So then you have to write that where df population, total population, df total population. So when I write df total population, that means I'm only talking about this middle column. I think somewhere here we have found also, yes, here. So I'm talking about only this column, and no, that is year column, and this one only total population column. So when I write df total population, I have already taken one subset from my data set, that I am only talking about the middle column. Now I will take another horizontal subset by another condition, and df total population equals 340. So that is what we are doing somewhere. Where is it? Yeah, here. So df total population, that will give me this column, this, and then I put this condition that total population also I don't want all entries, but I only want that entry where total population is 340. So that will give me, this means now this whole thing will give me this. And if I put the row, then loc, if I write, then location I have indirectly specified by saying that I have not specified the index, but I have specified that row where total population is 340. And when I use df.loc thereafter, then it will print this entire row. So this is more useful, because many times you have to conditionally print a particular row. This is just like in SQL you write that the where keyword, okay, that select column name 1, col 1, col 2 from table name, where column 1 dot value equals this much. So conditionally you are fetching one particular row. Okay, so that is what. Now let us create another such data frame. We have already seen that how data frame is created from dictionary, and that is why in the beginning of the chapter, very beginning of the chapter, here the definition was like this, that data frame definition, yes, this, that it is essentially a dictionary like container for series object. So a data frame can easily be created using a dictionary. So let us create this data frame. So this is one dictionary, this is another dictionary, and this is another dictionary. If I want to create data frame, then I have to take care that in all 3 dictionaries, or 4 also I can take, or 5, or any number of dictionaries, the keys must be common. So for the first dictionary, the 3 keys are name, age, and city. Then you can see that for the second dictionary also name, age, city, and for the third dictionary also the keys are name, age, city. But the values are different. They may or may not be same. So Alice 25 New York, Bob 30 Chicago, Chris 22 San Francisco. So like that. And comma separated list of dictionary you have to prepare first as your data. Once that data is prepared, you can use your standard method pd.dataframe, and in bracket you can find put the data, which is nothing but a list of comma separated dictionary. What kind of data frame is created? You can see that whatever common keys were there in all three dictionaries, those common keys, they have become column headers, and whatever values were there, they constitute one row. Alice 25 New York, this row. Bob 30 Chicago, this row. And Chris 22 San Francisco, that is this row. So keys create the name of the column and values create individual rows. Okay, and easily data frame is created. Once it is created, I can even find conditionally that find the row which has age greater than 25. So obviously what I am doing, first I am taking only age column, that is this df dot age, df age. I can even print that or add that in add one cell, and df age. So when I write df age, this shaded portion, actually I am selecting this much from my data frame, and then I put further condition that from the df age also only that which is greater than 25. So this is exactly 25 but not greater, and this is less than 25 but not greater. So this, so that will give me indirectly which index I am talking about. So in this much will give me that it actually find the first row, and then from the df, if you find the first row or take another subset or take the lock, okay, so then both ways you will get the same output. So people older than 25 are, this is obtained by taking subset of subset. Subset of subset means I explained that this is vertical subset, one column, and then this whole thing will limit me to this much only, so it will indirectly give me the row index, and then I have to take horizontal subset from that row index. So that is this whole thing. So that is this horizontal subset. Is that clear? Okay, fine. Now that people who are older than that, but instead of subset, you can also bracket portion remains same, df age. So first you find vertical subset from which find age greater than 25, so this much, and then instead of taking another subset, you use the lock operator, location operator, so that will give the data which is at that location. Okay, but both ultimately give same result. Okay, people older than 25 are only one, Bob 30 and Chicago. So I get that. Now coming to the most important portion. Okay, so please now pay attention. As I said, now we want to do about this loading data into the data frame. Now the upper picture is a very important picture. This covers what we are going to learn in our entire course, right from the beginning to end. But at present it is too difficult for you to understand. So at present you don't bother about it. But here you can see the whole, this is called data science life cycle, and it starts from here, goes in this manner, and goes this way and this way. Also it is iterative, so that means sometimes after coming up to this stage, you have to go back to this stage, and you have to do the remaining stages once again. Sometimes you have to iterate from the other stages also. So that means there are multiple iterations, branches, sub branches, like that. While iterating from all these, you have to go from here to here. You also have to sometimes go to this thing, feature engineering. Don't worry at all what are these things. That is what we are going to learn. Sometimes you have to go to this thing and all. But you can see that in very initial stage, the very first is data acquisition. That is getting the data. Now that is common sense that if you want to do anything with the data, then you have to have the data in first place. Okay. So data can be either at these locations as flat file on my PC, or it can be as a database, for example SQL database, okay, in a database management system, DBMS, or it can be some file on internet from where I have to download and then use in my data analysis, or it can be okay, this much. Now in this, as a flat file on my PC, again there can be many different types of flat files. For example, CSV, comma separated values, TSV, tab separated values, then XLSX, that is our standard and our favorite, the spreadsheet given by Microsoft Excel. So this thing, okay, or here it can be an SQL database in database management system, or you can get a file from internet. In short, when you try to load the data, the library which you use for loading the data should be versatile, and it should be able to handle all these different formats of data. Okay, not only this, but later on you will see that there are other formats like in big data like HD, FS. Then there is another format Parake. These are various different formats. So Pandas is so powerful a library that it can handle all these formats which I just now wrote. Okay, so let us start with the first file, CSV file, comma separated values. Okay, so suppose I have one file and you can see also data.csv. That kind of file is there in my same directory as my Jupyter script is there. So I can just write pd.read underscore csv. First, of course, you have to import pandas. Read underscore csv. This command is so powerful that it can import CSV data, TSV data, tab separated file, or it can even import data from the internet. Okay, so read underscore csv data.csv. Okay, so at that time this data.csv file is already there. So I have already kept it open also. So it is this kind of file, but it is not looking a picture which I have shown in this diagram above it. That is because when I open that file using Jupyter, then Jupyter actually makes a good tabular structure with it. So, but that is here, this data.csv, since I have opened with Jupyter, it has given a good tabular structure. And in tabular structure, there seems to be some error also. There is no, for example, column headers. So I can modify that file. But why its format at present is not looking what I was seeing in my that picture. So that we can, this picture I am talking about, this picture. Okay, why its format is not looking this way. So that is, you will see that format provided you go to that folder and open that file data.csv, that.csv file, but open it with Notepad. Jupyter converts it into nice tabular structure, but you open it with Notepad. Also, I can make one change here that I can add column header fname, comma, lname, comma, ssn. So that means first name, last name, and social security number. And I save that. Now, if I load it through the Jupyter notebook, I will keep that format also. This is not required. Where is that data.csv opened with Notepad? Then yes, this. So I will keep these also open so that you can see exactly it is now that kind of format, chain underscore Colby, chain comma Colby comma 475 and something. Okay, so that kind of format is there. I have added the column header. Now if I read it, if I open it using Jupyter, then Jupyter will give nice tabular structure automatically, and it will look like that our standard Excel spreadsheet or Google sheet or that kind of thing. Okay, now pd.read underscore csv and I put data.csv. So that will give me df1 first data frame, and then I can check also by putting whether it is properly printed or not. Okay, so this command will print first 5 rows. First 5 rows means these, and up to holding and kid. Similarly, tail command, df.tail, that will print last 5 rows of whatever, because this can extend below this. This is just a snapshot of it. In fact, it is extending. This is the, so it will print the last 5 rows. So that is maybe a little bit duplication is there, so that is fine, but it will print this. Okay, and then if I just write print data frame, whatever I have read using read underscore csv, if I print entirely, then it will try to print everything. If it is possible by Jupyter, Jupyter will print all the rows. So top 5 rows by head, bottom 5 rows by tail, and all the rows. If I just write name of the data frame, let us execute, and you can see this in between separator line I have provided like this. So this is the output of df1.head, this is the output of df1.tail, and this is the output of entire df1. Now there is one issue with Jupyter, that it cannot go on endlessly printing the output, because you can see that I have to scroll a lot because of these 47 rows. And if I increase a few more rows from here, say I take this whole data frame and copy below and save, and then I again try to print, then head and tail will still print first 5 and last 5. But now this print df1 tries to print all the rows, but it cannot, because Jupyter's capacity is to print a certain number of rows only. So then you can see top few and bottom few, and in between it just prints this type of dot 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 dot. Now that you can change, this behavior you can change by setting one environment variable that is called display.maxRows equals none. But that we will see whenever it is there. So it is possible that sometimes you may like to see each and every row, because there may be some special detail of interest between, say, in 45th row, but 45th row is not getting printed at all. So you may want to print all the rows, then you can do some adjustments, some one line of command code, but that we will see when it requires. Okay, so this is read underscore CSV. It converts a CSV file into Pandas data frame. Now, then what to do if my file is a TSV file? Okay, this is CSV. Now let me open tab separated TSV file. So that is this file. Open with Notepad, and if I open with Notepad, and okay, so now you can see the difference between comma separated format and the tab separated format. In the comma separated format also there are column headers, okay, and the values are separated by comma, but in the tab separated format column headers are there, but they are separated from each other using a tab character. Here I am at the end of first column name, and then if I press the tab character, then here tab, then I will go where the second was starting. Okay, here it was already there, then I will type the name of that second sepal width. Okay, so these are called tab separated data. And if I still prolong it, because the names are very long, and I should shift this so that you can actually understand which values are below which. Okay, so this is what is my tab separated file. Okay, sepal length is the column name and these are the values, sepal width is the another column name and these are the values, and so on. So that is how it was. I don't save it because you should have habit of seeing this type of file. It looks slightly confusing in the beginning that what is exactly the name of the file and where are the values. So actually this whole is the column name, and these are the values 5.1, 4.9, this, they are values under first column. This is next column name, and these are values under that column. Similarly, this is last column name, and these are values under that column. You can see that it is a heterogeneous data type like this, because some these data are floating point numbers, decimals, but this data type is string. It is some words are there. Okay, and now let me come back to how to read that. So again, read underscore CSV. But why read underscore CSV? My data type is file is not CSV file. My data file is TSV file. So I am trying to read this file now, not this one. So let me close CSV, and I am trying to read this file, which is my CSV file, TSV file. Sorry. So what to do? Then specify comma and another argument delimiter equals, and this is called escape character, that is backward slash, and T for tab. So here also that argument is there, but its default value delim equals, and then I can write a character and then escape character and a comma. So then this becomes a comma separated file. But even when you don't write it, by default Panda takes comma as the default delimiter. Okay, because most of the time we have to encounter, so delimiter is equal to tab separated file. Okay, but here you can specify explicitly, and still you will see that the behavior will remain same. Okay, so this is just warning, but you got all the output like previous one only. Okay, so Pandas give that much freedom that if it is only comma as a separator, then don't write anything. I will understand and I will produce the output for you. But for any other separator, you have to explicitly specify. So I am using read underscore CSV only, but you should understand that you are not reading comma separated file, but you are reading a tab separated file. That much is understanding will become clear if one reads the arguments which are in the bracket, and this delimiter clearly says that it is a tab separated file. Let us try to read and print ahead, and I should be able to see top 5 rows, because here there are only 5 rows, so I don't need to print whole data frame, because head itself will be the whole data frame. Okay, so now you can see that Pandas has automatically adjusted that problem. Here this is the length and its values are there, then this is the name of the second column and its values are here. But here you can clearly see name of the column, values exactly below it, the name of next column, values exactly below it. So nice representation is seen. Okay, now how to load from Excel file. So from Excel file only, that is the rare case where you cannot use read underscore CSV. Otherwise, Pandas has created a standard way of reading all types of file, maybe CSV or maybe TSV or maybe even some other paragraph file or some other file. You can read it by same command by specifying appropriate delimiter. Okay, but for Excel, since Excel is a proprietary format of Microsoft, So you have to install one library, this library, pip install open py excel. So that py stands for Python and excel stands for Excel. It's an open source library. Some people have found that it would be helpful to provide a method by which one can read Excel file, because Excel is a very dominant spreadsheet and large proportion of world's data is in Excel. So read underscore Excel and data.xlsx, and then you can write this. Okay, so you got exactly. Oh, I have not opened the Excel file, right? So let me open the Excel file for you, and you will see that it is the same data, but now it is in my Pandas data frame format. So now you can see that Excel file. I clicked using my Microsoft 365 only. I have opened, and this chain Colby and this again it is suppose first name, last name, and social security number. Okay, so again I should have added one row that would have been better. So I can insert a row here, and the column that would be column header. So F underscore name, then L underscore name, then SSN, and let me save. Let me read once again. This time I'm getting still better format. Okay, so this is my way of reading Excel file. Don't use pd.read underscore csv for Excel file. Instead, the command is easy to remember. I'm using reading Excel file, so read underscore Excel file. But for that, this library open PyExcel that will be required. There are other ways also for reading Excel file, but all require installation of one or other library. Now this is one more way of getting data. That is, data can be loaded directly from some URL location. Now that means what? The data is not present in on my PC, but it is present at this location. Okay, so let me first copy that location. I think I will not be able to, but let me try and paste in my browser. Okay, the last quotes and the initial URL and quote. I'm just directly trying to go to that location and show you. No, okay, yeah, my internet. Sorry. Okay, so I directly went to that location on the internet at this HTTPS, and a long address is there, and I found a sample file, very simple, first name, last name, and date. Three columns are there. Now that, will you download it and then put it in on your machine and then you will use in Panda? That is also one method. But read underscore CSV is so fast, so dynamic that you can write the entire URL here, and you can write data is equal to pd.read underscore CSV, then write your URL wherever your that file is located, and write a separator. Now that is required because that is just like that delimiter. So you have to at least open that file once and see what is that delimiter, comma is there or tab is there. And the most important argument is this: if you directly want to read from the internet, then you have to specify the encoding as UTF-8. Okay, and if you do that, that is, I will put all these arguments on one line because it looks as if it is something very some rocket science. It's not at all rocket science. It is very easy. Okay, so yeah, you can see that first argument is the URL, the location on the internet from which you would want to download file. Second argument is the separator, and the third argument is the encoding. Okay, so that's it. I think fourth argument, even this comma would not be required. It will create some error perhaps. No, it is not creating error, but I think without that comma also things would work well. Yes. Okay, so then this is the way to read data from internet. Now this approach is especially handy while working with updated data sources available on the web. By reading the data directly from the internet, you ensure that you are working with most current data available. Okay, so these capabilities, which capabilities? Ability to read from CSV or TSV or Excel or internet or Parquet or HDFS or any data format makes Pandas a powerful tool. The meaning of this thing you have to understand. Here, this sample file was very small, so it does not make any sense why we would do that. I can just download or maybe copy paste on a notepad and save on my PC. But the problem is that if this file continuously keeps on changing, say it is a streaming data, and that means these values continuously keep on changing. So at that time, what will you do? You have to read it from internet only, because as that file continuously keep on changing, your apps working should always use the most recent data. So if you keep a file saved on your PC, then that will not work. Okay, and from here we will start some basic data exploration using Pandas in next lecture. Thank you.